so we're going to add to our list today not only solving for y, but any literal equation at all. Equations. Which means it's probably in your best interest right now to just take one deep breath. And don't freak out, because my students look at these problems and instantly tell me that they can't do them. Because when we look at literal equations, we are not going to see any numbers at all. Everything is going to be a letter. Now, good news, bad news, just like we said on Friday. Okay, the bad news is yes, everything is a letter, and so it looks like something we have never seen before. But the good news is that it's exactly like what we've seen before, and there's actually less computation because we can't do anything with those letters. We're just moving them to the other side. Okay, so we can have something very simple. A plus B equals C. I am making up this formula. This is not an actual formula. I'm making it up because I don't want to start with something super hard. So we're going to start simple, and Mrs. McKinney is going to give you some weird equations just to do simple problems. Okay, so right, this says A plus B equals C, and what does this arrow to B tell us to do? Solve it for B. Okay, so just like we were doing on Friday, we want to think about those same concepts. Right, we said if x and y were on the same side, we were going to move the x with addition and subtraction. Well, we were really doing that because when we're solving an equation, we're doing order of operations backwards, and that says to undo any addition and subtraction first. Okay, so is there any addition or subtraction happening over here with the b? Yes. What letter is attached with addition and subtraction? A. Is that a positive or negative? Positive. So this is a positive A. And just like we have been doing for weeks, how do we undo something that is positive? Subtraction or a negative. Okay, and whenever we write something underneath on one side of the equal sign, what do we also have to do? Write it on the other side of the equal sign, right? So we're coming over here now to the right-hand side of the equal sign, and we are putting the exact same thing. Just like we have been doing, these A's cancel out. What is C minus A? C minus A, right? We can't do anything with it. It's actually less mental work because we are just going to bring down what we have left. So a B is coming down, and we have a C minus A. Morning. Yep. Does she need to bring her things? Okay. Okay, all right, thank you. Telephone office. Okay, so is B by itself? Do we say B equals something?
Yeah.
Yep, is there anything else over here with the B? Nope. So we are done. And my student's like, oh, that wasn't so bad, right? We're just undoing operations that we see. So here's one, and we already talked about this. D equals R times T. What formula is this? Distance equals rate times time. And let's solve this for R. So this is actually something you're going to have to frequently do in your ICP class. Okay, so if we want to solve this for R, our objective is to get R by itself on one side of the equal sign. Okay, so what is sitting over there with the R? A T. What operation is happening in between R and T? How do we know that it's multiplication?
You guys are right next to each other.
Right? When we don't see an operation at all, the operation is multiplication. So we know that this is multiplication. Okay, our rule is that whatever variable we're solving for, right, is the one that we do not put down. We don't actually want to write down what we're solving for. We just want to put down whatever we're moving. Okay? So if multiplication is holding these together, how do we undo multiplication? Division, and what are we going to divide by? T, right? Why are we dividing by T? Because we want to get R by itself. The T is being attached with multiplication. We undo multiplication with division. Whatever we write on one side of the equal sign, we also have to write on the other side of the equal sign. Okay, so what's canceling out over here? T's. What is D divided by T? D divided by T. Now, you might want to rewrite this so it says R equals, right, and just swap the sides. These would be the same thing. Those both say the same thing. Okay, but we have R by itself on one side of the equal sign. How are we doing so far? Right, this isn't terrible. We're telling ourselves that statement. This isn't terrible. I can do this. This isn't so bad. AB plus C equals D. And we want to solve this for B. Right? Keep telling yourself what you were just saying. This isn't so bad. I can do it. No problems. Right? It's math I already know how to do. I took a quiz. I'm confident I know my steps in inverse operations. So we want to solve this for B. Okay, do we agree that there's two numbers sitting over here that we need to move? What two numbers do we need to move? A and C. So we have to make a decision. Which are we going to move first? Are we going to move C first, or are we going to move A first? What do we think?
C.
Okay, so for those of you who say C, who can give me a reason why we're moving C first?
I don't really know if it's right.
Why do you think you're going to move C first?
Because it's like by itself. It's not like attached to anything to do with subtraction.
So there is a reason that goes along with that, Chloe.
Is it because it's inverse of operations backwards?
Right? We're doing our order of operations backwards, which says to undo addition and subtraction first. How is this C attached? Addition. How is this A attached? Multiplication, right? So we have to undo the addition and subtraction first. So how do we undo adding C? Subtracting C. So if I subtract C here, I also have to subtract C here. Okay, so what's going to cancel out? C's. Okay, so I'm bringing down my AB that I have left. What is D minus C? D minus C. Okay, what operation's holding A and B together? How do we undo multiplication? Division. So I'm going to divide by A. I mean, we don't know what any of this is divided by A, so we actually have a couple ways that we could represent this. This is our pretty standard option because we don't know what any of that is. right? So we'd say B equals D minus C over A. But would we be wrong if we wrote this? No, right? Those are both the exact same thing. So you'd be fine no matter what option you wrote if it was free response. The trick is multiple choice and making sure that you're finding whichever one is there in multiple choice. That's where multiple choice can be really tricky because the answer doesn't have to look exactly like what you put. You have to find something that's equivalent to what you put. How do we feel about that one? Okay, we're gonna look at one more. A equals 1/2 BH. Anyone know what this is? What is this formula? Area of a triangle, right? Area of a triangle has the formula area equals 1/2 base times height. So let's solve this for B. Okay, and we're going to talk about something that we can do here. With a lot of formulas, especially if we are talking about area or volume, there is a lot of multiplication happening. Right? So if we're talking about the volume of a prism, we're looking at length times width times height. Right? There's multiple things sort of being multiplied together. So if we want to solve this for B, what two things do we need to be moving? Okay, 1/2 and H. Okay, so if we're moving 1/2 and H, how is the 1/2 attached? Multiplication. How is the H attached? Multiplication. So which one am I going to do first if they're both attached with multiplication? It doesn't matter. So you have a couple choices. You can just randomly pick which one to move first, or you can just move them together. Just move both of them at the same time. Okay, how do we undo multiplication? Division. So it is okay, since it is all just one operation, for us to divide by both pieces at the same time. And my students go, but Mrs. McKinney, that doesn't seem to make any sense because those are in completely different places. But what if I wrote this in a different order? What if instead of it saying 1/2 times B times H, what if it said 1/2 times H times B? Then would you feel more okay with dividing by that 1/2 H at one piece together? Is it okay for us to change the order of multiplication? What property allowed us to change the order of multiplication? So, right, we had commutative, associative, distributive, inverse, identity. Which one allowed us to change order? Change order, C-O. Commutative. This was the commutative of multiplication. So remember when I told you that, like, those properties being something that we can always, like, label or use the terms perfectly for aren't the key, but it is our rule book. It's what tells us it's okay to divide by these together. Okay, so if we divide over here, we're also going to divide over here. Okay, and these cancel out. Now my students are fine with a B. And they're fine with this. Like, okay, sweet, I'm done. Except we have a dilemma. You are never going to see this as an answer in multiple choice. Why not? What feels weird about this problem?
Because it's like a fraction divided.
Right? We have a fraction within a fraction. Do we write fractions within fractions? No. So what are we gonna do? How are we gonna get rid of that fraction down there?
Turn it into a decimal.
Times it.
But even if you put it as a 0.5, a decimal within a fraction probably isn't good either. What do we say?
Multiply 1/2.
I don't want to multiply by 1/2, but you're starting to get to the right place. Divide what?
1/2. Oh, the A.
What number? Right, so A divided by 1/2, that's kind of weird. What number is sitting right here in front of the 1? In front of the A? Oops. I do that all the time. A 1? And don't we agree we could do 1 divided by 1/2? Right? Because when we're dividing by 1/2, we are really multiplying, but by the reciprocal, the flip-flop of it. Dividing by 1/2 is really multiplying by 2. So 1 divided by 1/2 would be 2. And this would be our answer.